Hi, question number 5 taken from October 2002, Advanced Level Maths HSC S2. X and Y are independent random variables, each having a Poisson distribution. X has mean 2.5 and Y has mean 3.1. First part, we need to find the probability that X plus Y is greater than 3, and for the second part, a random sample of 80 values of X is taken, and for that one, find the probability that the sample mean is less than 2.4. Okay, so what do we have? Number 5, the first part, we have X follows a Poisson distribution with mean 2.5. Y follows a Poisson distribution as well, mean 3.1. So X plus Y follows a Poisson distribution with mean lambda. This plus that's going to be 5.6. We need to find the probability that X plus Y, okay, is greater than 3. Now for this one, it's going to be exactly the same as 1 minus the probability that X is equal to 0, 1, 2, and 3. Therefore, we're going to compute all these probabilities. So, what are the probabilities? But first of all, okay, so X plus Y being greater than 3 is going to be exactly as 1 minus the probability of X being 0. So, that is going to be e to the power of minus 5.6 plus e to the power of minus 5.6 times 5.6 over factorial of 1 plus e to the power minus 5.6 times 5.6 to the square over factorial of 2 plus e to the power of minus 5.6 times 5.6 to the cube over the factorial of 3. So you're going to add up all these and you're going to end up with 1 minus. Now if you do these on your calculator, okay, so for the first one, e to the power of minus 5.6, so then e to the power of minus 5.6. Okay, so we have 0.003697863 plus for the second one, so you multiply by 5.6, it's going to give you 0.020708 plus the 1 to the square, so we got then e, alright, to the power of minus 5.6 times 5.6 to the square, all divided by factorial of 2, 0.0579. So we have 0.05798, okay, 2503 plus e to the power of minus 5.6, but this time times 5.6 to the cube, and divided by factorial of 3. Okay, that's going to give us 0.108. 23405, and you add all of that up from your calculator, you're going to get 0.190622407. So therefore 1 minus 0.190622407, so 0.809. Okay, 377 so on. Therefore the answer is 0.80923 significant figures. Here we are for the first part of the question. Now for the second part, a random sample of 80 is taken. Remember, if n is greater or equal to 30, then we can use the Central Limit Theorem. Alright, so what is it? We have a sample and we need to find the probability that the sample mean is less than 2.4. Find probability that sample mean, that is x bar, is less than 2.4. Okay, so we have a situation. Alright, and what is it? So, okay, x follows then a normal distribution by Central Limit Theorem, because if it's greater or equal to 30, the distribution will become a normal distribution. Alright, and the mean sample is then what is, okay, so where do we go from here? The mean sample of x is 2.5. Yeah, that was what I was looking for. 2.5, and the standard deviation will be the sample, so it will be the 2.5 divided by 80, all right, or the equivalent of that, so but that's fine. Now from here, we're going to have to find out that x is less than 2.4. That is exactly the same as the probability of z, if we standardize, being less than 2.4 minus 2.5, all divided by the square root of the standard deviation. The square root of 2.5 over 80. And okay, so we're going to have to work this out, and that's going to be probability of z being less or equal to, there's a negative there. Alright, so I have 2.4 minus 2.5 divided by the square root into brackets of 2.5 divided by 80, and that's going to give us minus 0.5656. Alright, so I got minus 0.5656 and so on. So if we look at that from the standard distribution, normal distribution curve, if this is minus a, p of z being less than minus a. Okay, so we're going to reflect it there. That's going to become p of z being greater than a. In other words, 1 minus p of z being less than a. Therefore, we're going to look for this. So it's going to be 1 minus xi of 0.5656. And if you check that out on your table, from your table, it's going to be 1 minus this one. I'm going to write this here. Okay, I'm going to write from table. Okay, from table you're going to get it as 0.7143. Therefore, I got it 1 minus 0.7143, okay, and that's going to give us 0.2857. So 0.2857, and to three significant figures we have 0.286 to 3SF, and here we are, x being less than, the mean being less than 2.4. Well, I hope you've been able to get some help from this one now.